Hi, this instructional video is about complex numbers. Particularly, it's about writing such expression as a standard form. Now, keeping in mind, the standard form is given as a plus bi, a constant and a coefficient with an I term. Okay? And the rule is, when you have a quotient, the denominator cannot have a complex number such as this, or a radical, in fact. We done this in Algebra 1 when we dealt with rational equations. So to simplify this, what we have to do is to multiply to the top and the bottom of the quotient by the conjugate of this binomial, the conjugate. So the conjugate of a 5 plus 2i is 5 minus 2i. And we do that to top and bottom. So what is required at this point is the distributive property of the two binomials. Okay? And remember that I is defined as square root of negative 1. So that means I squared is in fact square root of negative 1 times another negative 1. So what comes out is negative 1. That being said, we could do the distributive property here. First, the 2 times 5 is 10. And 2 times negative 2i is negative 4i. Now the middle term, 5i times 5, they're both positive, so it becomes 25i. And 5i positive times 2i negative, positive and negative is negative 10i squared. Over, now the bottom, the 5 times the 5 is 25, and 5 times a negative 2i is negative 10i. Now the second term, or the inside terms of the two binomials, 2i times 5 is positive 10i. And 2i positive times a negative 2i is negative 4i squared. Let's simplify the numerator. What you end up getting is 4i negative and 25i positive becomes 21i. Okay? Minus the 10i squared. Over. Now, when you take the conjugate of a binomial, the middle term always cancels out. That's the beauty of it. So what you end up is 25 minus 4i squared. And now, remember, I squared was defined as negative 1. So in fact, what this last term says is negative 10 times negative 1. So it becomes plus 10. So plus 10 combined with this constant 10 becomes 20 plus 21i over, same thing here. That last term, negative 4, and I squared is negative 1, so that becomes plus 4. So 25 constant plus 4 on the bottom gives you 29. And this is a good form, because as long as the denominator is not a radical or a complex number embedded, it's a good answer. And now, oops, yes, it's a doorknob. Now you try this one. Good. And you said, all right, so now, same thing as the last one. Since we have a binomial on the bottom, we're going to multiply its conjugate to the top and the bottom of the quotient. So what happens, we're going to have to do the distributive property, the FOIL method, that is. Remember, FOIL? So we're going to first multiply the first of the two binomials, negative 7 and 9 gives you negative 63. And negative 7 times positive 4i is going to be negative 28i. Finally, the inside terms, 6i positive times 9 positive gives you positive 54i. And positive 6i and positive 4i gives you positive 24i squared. Over, now the bottom terms, the first of the two binomials, 9 and 9, gives you 81 when you multiply. Now the outside terms, 9 and 4i positive gives you positive 36i. Here, of course, the inside terms out, negative 4i and positive 9 gives you negative 36i. Remember, the conjugate always gives you two middle terms that will cancel out each other. And finally, the last of the terms, negative 4i, positive 4i, gives you negative 16i squared. Let's combine, simplify the numerator. So on the top, we have negative 28i and positive 54i, and that becomes positive 26i. Okay, plus the 24i squared and negative 63, the constant, over, yeah, the bottom, the middle term cancels, their additive inverse. So you end up with 81 minus 16i squared. Now remember, here we go again. Remember that the I squared is defined as negative 1. See? So what in fact you get is 24 times negative 1 is in fact negative 24. So you take that negative 24 combined with negative 63, you end up getting a bigger negative, which is going to be negative 87, plus the 26i, over this one also, negative 16, and I squared is defined as negative 1. So negative 16 times negative 1 is positive 16. And we're going to combine that with this constant 81, which will give you 97. And so, this is our final simplified form of this quotient involving imaginary numbers, the complex number system. Very good.